All right. Good morning, students. Good morning, all of you. I hope you are able to hear me. Good morning, Sagar. Morning, Adesh. Morning, Sakshi. Yes. So, yeah. So let's begin with. I'm good, Somnath. Thank you, Lavanya. I don't know how you got that. I don't know how you got that, Lavanya. Sir. Yes, Ganesh, you are 100% correct. Thank you, Ketan. All right. So let's begin then. Right? So all of you must have understood this is not a very peculiar problem. It's a common problem for hydrogen, right? So yes, Jyoti, unfortunately. So yeah, so when the hydrogen got arrested, we could not make a call because we don't know whether he belongs to the first group or 17th group. His position is still anomalous. His position is not yet finalized. Correct? Morning, Aditya. Finally, you woke up. I'm hoping you woke up. Hydrogen got arrested because he was showing some chemistry with oxygen. That's why he got arrested. Okay? Chalo, let's start within no time. Okay. So yeah, this is your first recall test. This is your recall test for the today. Which element in 3D series can exhibit +1 oxidation state? You cannot get anything easier than this. Chalo, then don't disappoint me. Give me a correct answer. You cannot get anything easier than this. Yes, I think most of you are getting it correct. So I'll give you another 10 seconds for this. Finish it off in a go. Yes, so let's end it on a count of 3, 2, 1, now. All right, so all of us have studied that copper can show copper +1 as well as copper +2. So +1 can be exhibited by copper, but copper +2 is exhibited only in, I told you copper +2 is stable only in Siddharth. No, beta, chromium is not possible. We had discussed this. So copper 2+ is possible only in aqueous state. Correct? Why? What the reason? What was the reason we gave? We gave the reason that in aqueous state, the hydration energy released compensate. In aqueous state, hydration energy released compensate second high ionization, or you can say ionization energy 2 of copper. Compensate ionization energy 2 of copper. Correct? This is what we had explained. All right then. Let's move to our next things which we need to discuss today. Right? So we were discussing about oxidation state. We have discussed some things about oxidation state. Let us discuss them first before we go ahead. So we had seen three things. One was, why Adesh? So we had discussed transition metals or transition elements show variable oxidation state, right? So transition elements show variable oxidation state. What was the reason we gave? We gave the reason that energy gap between 3D and 4s is very less. So both the electrons of 3D and 4s participates in bonding. Therefore, they can show more than one oxidation state. Correct? Right. The next thing we saw was, what did we concluded here? We said scandium and zinc do not show variable oxidation state. What was the reason for that? Zinc can show only +2 because after losing 2 electrons, it becomes fulfilled and stable. So it cannot lose any other electron, right? So zinc shows only +2. And I told scandium shows only +3. What was the reason we gave? We said after losing 2 electrons from 4s, it will be 3d1. But I said you, scandium +2, that is 3d1 is highly unstable because after losing this 3d1 electron, it will become 3s2 3p6, which is again fulfilled. So it will easily lose its 3d electron and it will lose total how many electron? 2 + 1, 3. So it will show +3. Correct? This is what we concluded here. And we saw the oxidation states of different elements. Titanium can show +2, +3, +4, +2, +3, +4, +5, +2, +3, +4, +5, +6. Manganese shows maximum oxidation states till +7. Then iron till +6. Then last, cobalt and nickel +2, +3, +4. Copper +1, +2. Zinc only +2. Correct? Then we concluded which is the most stable oxidation state. +2 is the most stable oxidation state. Why? Because in all of them, outermost electrons are 2. 4s2, most of them. So most of them may outer electrons are 2, so it can easily lose 2 electrons to show the oxidation state of +2. Now coming to this, they each group, scandium के लिए most stable is +3, or you can be asked a question, name a element whose +2 is not stable. Name a transition metal in 3D series whose +2 is not stable. Then your answer would be, which transition element? Scandium. Scandium ka +2 is not stable. Correct? So for scandium +3 is stable, titanium +4 is also stable, vanadium +5 is also stable, chromium +6, manganese +7. These elements, these oxidations are also stable because after losing these many electrons, it will become fulfilled stable electronic configuration. We had discussed iron does not show +8. What was the reason we gave? We gave only unpaired electrons are participating in bonding along with 4s. So 2, 3, 4, 5, 6. Right? So the ionization energy is very high so that you cannot unpair this electron. Right? The energy required to unpair this electron is very high. Therefore, this electron pair does not participate in bonding. Correct? Is that clear? Therefore, iron cannot show +8. It shows only +6. Right? This is what we have concluded in last class. Let's move ahead to today's class. Yeah. Now here I come. So you can see here, these are the elements which show the highest oxidation state in your D block series. In the whole D block, these are the elements which can, D block element which can show maximum oxidation states. Manganese can show +7 in which compound? KMNO4. Ruthenium and osmium can show +8. Now you should know where ruthenium and osmium lie. So let me show you the table. Ruthenium and osmium lies below iron. Now, what should be our question? Ruthenium and osmium lie below iron and they show +8 oxidation state. Then what should be our question here? What should be our question here? Anyone? I don't know whether you get this doubt or not. I am getting it at least. Yes? What should be our question? Why iron don't show but ruthenium and osmium does? Correct? Yes. Now, you yourself know the reason. What reason did we give? Why iron does not show? Iron was 3d6 4s2. So if iron is 3d6 4s2, what reason did we give? We gave the reason that this is 4s, this is 3d. What was the reason we gave? We gave the reason that the energy required to unpair this electron or the energy required to remove or excite this electron is very high. So ionization energy is very high. Correct? So it does not show +8 due to high ionization energy. Correct? Yes. We can say that. Now, going to osmium and ruthenium, what happens? As you go down the group, ionization energy decreases. So their ionization energy is lower or less than iron. Right? Therefore, the energy required to unpair the, you can say this will be 4D, this will be 4d6 5s2, let's say, and 5d6 6s2. So the energy required to unpair the 4d or 5d electron is not very high. So after 4s, you will have 4p. So the energy required to unpair the electron from 4s to 4p is less energy. Therefore, you can excite this electron from 4s to 4p here so that it can show +8. So that it can show +8. Is that clear, everyone? So the question is why iron can't show +8, but ruthenium and osmium can show +8. Right? Is that clear, everyone? Because no, Ketan, that will in fact increase the ionization energy. Right? In which state it shows +8. That we need to check. Most likely in solid state only. So now you check. See this carefully. One very important fact. These three compounds show maximum oxidation state. Maximum oxidation state for manganese, ruthenium, osmium is found in these three compounds. What is the common thing you find in these three compounds? What is the common thing you find in these three compounds? Yes, very good. Very good. So highest oxidation state is shown in which element? In oxides. Why only in oxides? Because oxygen have more electronegativity. Oxygen has high electronegativity. We'll come back to this question again. Why only oxides? We will answer this today only. Don't worry. Right? Don't worry about it. We will answer it today only when we have it in future. Okay? Like coming 5-6 slides ke baad. Yes. Is that clear, everyone? Yes. Do you guys got this right or not? We use osmium tetroxide in organic also. Yes, Pritesh, you are very much right. You use organic में osmium tetroxide. When you treat your alkene with osmium tetroxide, it forms syndiol. For those who remember, it gives you syndiol. That means both OH will be on same side. Yes. Chalo. Great. Let's move ahead. Right. Now there is an important fact here. We will try to understand it. Right. All of you, please pay attention. Manganese, these are the oxides. MnO, MnO2, Mn2O7. Let us find their oxidation state. So oxidation state for MnO is +2, MnO2 is +4, Mn2O7 is +7. I hope all of you know how to find oxidation state. In case you don't know, I will solve one for you. Manganese oxidation state, you can assume it to be X. How many manganese are there? 2. So 2 into X, or simply you can write 2X. Then oxygen oxidation state is -2. How many oxygens are there? 7. Overall charge on Mn2O7 is 0. So you get x minus 14 equal to 0, 2x equal to 14, x equal to +7. So this is how you find the oxidation state. I did not get it at Adesh. 0 oxidation state matlab? I did not get that, Adesh. So oxidation states you can find. Now, how can we correlate this? This is a very easy fact. You don't need to by heart it. It's a combination of 2 to 3 things, right? As you increase the oxidation state, we are saying ionic character increases. As we increase the oxidation state, we can say ionic character increases, right? Where have I mentioned 0 oxidation state? In the previous slide. Where, Pratish? In FeCO5, yeah. FeCO5 में oxidation state will be, this thing guys pretty obvious. There is no explanation needed here actually, right? Nickel and iron can also show 0 oxidation state in carbonyls. Why? Because carbonyls are neutral compounds. So you can assume iron as X, carbonyl is 5 into 0 equal to 0. So oxidation state of iron and nickel will be 0 here, right? So why they can show 0 oxidation state? This belongs to a class of compounds called coordination compounds. This thing good that you have asked. We will explain this in coordination compounds, right? Because this is a class of metal carbonyls. There is a synergic bonding and all involved here. We will explain this in coordination compounds. For now, you just remember in metal carbonyls, metal compounds with carbonyls, oxidation state is 0. Right? Is that clear, everyone? Metal carbonyl coordination, we will explain them in coordination compound. Why 0? Correct? Carbonyl are neutral compounds. Basically, they are ligands, but I don't want to use those terms now. Next chapter only we will discuss this. Next chapter is coordination only. So don't worry, there we will discuss it in detail. Okay? Right. So here, as you increase the oxidation state, ionic character will increase or decrease. It will decrease. Why it will decrease? How can we explain this? Very easy. Apply Fejan's rule. Apply Fejan's rule. Right? What is Fejan's rule? What is Fejan's rule? Fejan's rule depends upon polarization. It says covalent character in a compound. Covalent character in a compound is directly proportional to polarization. Is directly proportional to polarization, and polarization depends upon cation and anion. Cation and anion. right? So cations usually polarize anion. So anion get polarized by cation. So therefore cation have polarizing power. So polarizing power of cation is directly proportional to charge upon size. Whereas anion have polarizability. Polarizability is directly proportional to charge and directly proportional to size. Correct? So more is the polarization, more is the covalent character. Now you check here. We are talking about cation oxidation state. As you increase the charge on cation from +2 to +7, charge on cation increases, polarizing power of cation increases, polarization increases, covalent character increases. That means down the group, as oxidation state increases, covalent character increases. That means ionic character decreases. Correct? That means which will be most ionic. MnO is most ionic, Mn2O7 is least ionic. Or you can say Mn2O7 is most covalent. Most covalent. Is that clear, everyone? Yes. Is that clear, everyone? First point. Why ionic character decreases with increase in oxidation state? Is that clear? Very good. Now, let us move towards acidic character. Let us move towards acidic character. How can we explain the acidic character? Right? You think it from this point of view. Metals form, I will explain it like this. Metals form or better, let me write, metals form basic compound. Whereas non-metals form acidic compound. Correct? Metals form basic compound, non-metals form acidic compound. Very important. Now what we can see here, as you are going down the group or as you are increasing the oxidation state, so +7 will have more tendency to lose electron or gain electron. +7 will have more tendency to lose electron or gain electron. If Mn is having +7 charge, so it will try to donate electron or it will try to accept electron. Yes, Mn has +7 charge. That means it has already lost 7 electron. So now it cannot lose any more electron. It will try to gain electron. So Mn+7 has high tendency to gain electron. Correct? And what is high tendency to gain electron known as? The tendency to accept electron is known as what? Tendency to accept electron is known as what? Which species exists? Array, addition of electron is reduction. I am saying which compounds accepts electron, or to lose electron is the property of what? To lose electron is the property of what? Metals. And to gain electron is the property of what? Non-metals. So since it has high tendency to gain electron, you can say it is highly non-metallic, or it has high non-metallic character. High non-metallic character. Why? Because metals have tendency to lose electron, non-metals have tendency to gain electron. Since Mn+7 has high tendency to gain electron, therefore we will say it has high non-metallic character. Is that clear? Similarly, I can say +2 is low non-metallic character. Low non-metallic character. So as you can see, from +2 to +7, non-metallic character increases, and non-metallic compounds form acidic compounds. Non-metals form acidic compounds, and +2 to +7, non-metallic character increases, that means +7 will form which compounds? Acidic. And +2 will form which compounds? Basic. And +4 is amphoteric. So as you increase the oxidation state, acidic character increases. Why acidic character increases? Because non-metallic character increases, right? So non-metal form acidic compounds, and with increase in oxidation number, non-metallic character increases. Therefore, acidic character increases. Is these 2 points clear to you guys? Is these 2 points clear to you guys? It means higher is the oxidation state, more is non-metallic character, more is the acidic nature. This was there in periodic properties also. Ionic character, once again. Ionic character, Fejan's rule athar. Fejan's rule says covalent character is directly proportional to polarization. Polarization is a process, right? Where cation attracts the electron cloud of an ion. So cation causes polarization, therefore cation has a polarizing power. An ion gets polarized, therefore an ion has a polarizability. More is polarizing power of polarizability, more is polarization, more is covalent character. Directly proportional. Now polarizing power of cation depends upon charge on cation and size of, inversely proportional to size of cation. Whereas polarizability is directly proportional to charge and directly proportional to size of an ion. Now here you can see charge of cation is increasing. So as charge of cation increases, polarizing power increases. As polarizing power increases, polarization increases. As polarization increases, covalent character increases. So as you go down the group, covalent character increases. So ionic character will decrease. Is that clear, everyone? It was there in your Fejan's rule was there in your chemical bonding also. Yes, you can say that. You can definitely say that, Aishwarya. That was my next question, which I wanted to ask. But okay, you went smart at it. Yes, is that clear, everyone? So let's open a bottle of Sprite. Very good. Yes, great. So let's do a question on this then. I will not explain it now. I will explain it after the question. Yeah, one more thing I want to discuss here is see this. See this carefully. Just like iron we have discussed, it cannot show +8, but ruthenium, osmium can show +8. So chromium, molybdenum, tungsten, all of them can show +6 oxidation state. Most stable oxidation state for molybdenum and tungsten. Molybdenum and tungsten can show +6 oxidation state as most stable oxidation state. Most stable oxidation state. Whereas for chromium, +3 is, whereas most stable state for chromium is +3 and it will act as an oxidizing agent, right? So chromium +3 is stable, right? So now you can see here again higher oxidation state is stable for the heavier elements, that too with oxides. So same thing which we had discussed for iron. Same thing which we have discussed for iron. Chromium shows lower oxidation state, whereas the heavier elements show higher oxidation state as their stable state. That too with which element? With oxides. Right? Same as iron. Let's do a question on this. You can see the question in front of your screens. Now there are a lot of information which has been gathered in these slides from NCERT textbook. When you read it, the NCERT has given the statement but not the options, right? So options are not given by NCERT. Why? That reasoning part you have to think on your own. Right, so identify the incorrect statement. FeO is more basic than Fe2O3. FeO is more ionic than Fe2O3. Fe2 plus compounds are less volatile than Fe3 plus compounds. In Fe2 plus compounds are more easily hydrolyzed than Fe3 plus compounds. Last 2 points are little logical, but whatever we have discussed in the previous slide, if you use that, you can answer this question. Let me give you the options. Incorrect statement you have to identify. Please check this carefully. Please check this carefully. You have to identify the incorrect statement. All right. So we have got some responses. Very good, Athar. Sanat, beta, check again. Sanjana, Naren, check again. Chetan, you're right. Prajwal, right. Danush, right. Danush, wrong. Check again. Vishal, right. Anirudh, right. Chalo. Let's end this on account of 3, 2, 1, now. Yes. So we can see here, we'll check all the 4 options. So this is the typical inorganic question. This is how the question comes. Every statement has to be checked. First statement is correct. FE is plus 2 here. FE is plus 3 here. So he's saying plus 2 is more basic than plus 3. We have said as the oxidation state increases, acidic character increases. So plus 3 will be having more oxidation state, so it is more acidic. So if plus 3 is more acidic, that means it is less basic. That means FeO is more basic. Correct? Can we say that? We are saying oxidation state is directly proportional to acidic character. So therefore, here oxidation state is plus 3, here it is plus 2. So oxidation state is more, so it is more acidic. So if it is more acidic, it is less basic than FeO. Right. Now FeO is more ionic than Fe2O3. This statement is also correct. We have said oxidation state increases, ionic character decreases. So we can write oxidation state is inversely proportional to ionic character. So here you have plus 2, here you have plus 3 iron. So as oxidation state increase, ionic character decrease. So Fe plus 3 has more oxidation state, less ionic character. So Fe2O3 will have less ionic character than FeO. So FeO is more ionic than Fe2O3. That is also correct. Now coming to this, Fe2 plus compounds is less volatile than Fe3 plus compound. True or false? True or false? Let us check. Fe2 plus compounds, we have just now said, is more ionic. So it is more ionic and it is less ionic. What does it mean? What does it mean? If Fe2 plus is more ionic, it is stable. Ionic bonds are more stable. This is less ionic, or you can say it is more covalent. Ionic bond is a stronger bond than covalent bond. So if it is more ionic, it is more stable bond. And if it is more stable, will it vaporize? No, it will not vaporize. So is it volatile? No. More is the ionic character, less is the volatility. Less is the volatility. Can I say that? Can I say that? Yes or no? Yes, I can say that. Right? Now you check the last option. Fe2 plus compounds are more easily hydrolyzed than Fe3 plus compounds. All of you have studied a lot of chemistry till now. can you tell me what is hydrolysis process? Can you tell me what is hydrolysis process? Can you tell me what is hydrolysis process? Breaking in water, breaking of bond in water. Let me tell you one thing. Hydrolysis process is the concept of covalent bonds. Ionic bond may usually hydration happens. Hydrolysis is a process of covalent bond. Now, if I take Fe2 plus compounds, they are more ionic. They are more ionic. Whereas Fe3 plus bonds are more covalent. So now, can you tell me which bond will be broken easily? Fe3 plus or Fe2 plus? Which bond will be broken easily? Fe3 plus or Fe2 plus? Which bonds are weaker? Fe3 plus. So water can break whose bond easily? Fe3 plus. So who will get hydrolyzed easily? Fe3 plus gets hydrolyzed easily. Fe3 plus get hydrolyzed easily. And if it gets hydrolyzed easily, then this statement is wrong, which says Fe2 compounds are more easily hydrolyzed. So that means your option is D. That means your option is D. I would say this is a JEE main NEET plus NEET type question. Right? JEE main plus NEET type question. Is that clear, everyone? Any doubt in this? Is that clear, everyone? Yes. So very good. So let's move ahead then. We are going to our next concept. That is this. Right? So we are going to study about reduction potentials. We are going to study about reduction potentials of M2 plus ion to M ion. For example, copper 2 plus 2 copper. We are going to study standard reduction potential of these elements. Okay? Now before that, let us see some reactions. Copper plus HCl, no reaction. Actually, copper plus dilute H2SO4 or dilute HNO3 also, no reaction. There will also be no reaction. So this reaction won't take place. Right? So dilute H2SO4 and dilute nitric acid, no reaction will take place, but copper with dilute concentrated H2SO4. So copper with concentrated H2SO4, they also act as very good oxidizing agent. They can give you copper sulfate. You can do the balancing part, plus SO2 gas, plus water. So with concentrated H2SO4, reaction can take place. Now my first question is, why copper does not react with HCl or dilute H2SO4? Why copper does not react? Anyone? Why copper does not react with dilute HCl? We have studied this in Pritesh, you need a better explanation. We have studied it in electrochemistry, right? So we have studied, if you react it, let us say it react. So copper will react with HCl to form copper chloride plus H2, let us say. So hydrogen goes from 0 plus 1 to 0, whereas copper goes from 0 to plus 2. So copper undergo oxidation and hydrogen undergo reduction. But we know reduction potential of copper is 0.34 and reduction potential of hydrogen is 0. Right? What does that mean? That means copper has more reduction potential than hydrogen. So if copper has more reduction potential than hydrogen, then how can copper get oxidized? Therefore, this reaction don't take place. Right? But with concentrated sulfuric acid and nitric acid, it takes place. Why? Because you can see here, why this takes place. Nitric acid will get NO2. Correct? Why this reaction takes place? Because H2SO4 and HNO3. H2SO4 and HNO3. are very good oxidizing agent or are very strong oxidizing agent. Why? Because sulfur oxidation is +6 in sulfuric acid. It cannot further increase its oxidation state. Maximum oxidation state of sulfur is 6. So it cannot increase its oxidation state. That means it cannot undergo oxidation. But it can decrease its oxidation state from +6 to +2, +4. So it can undergo reduction, therefore it acts as very good oxidizing agent. Right? Is that clear, everyone? Is that clear, everyone? That's the reasoning part. Which part, Mahavir? Mahavir, which part, beta? Strong oxidizing agent. So you can see here, sulfur oxidation state is +6, which is maximum for sulfur. So sulfur cannot oxidize. It cannot increase its oxidation state to +6, +7 or +8. This is not possible. It can only decrease its oxidation state to +2 or +4. That means sulfur can only undergo reduction in sulfuric acid. So if it undergo reduction, then it is a good oxidizing agent. Correct? Is that clear, Mahavir, now? Sulfur cannot oxidize because it is present in highest oxidation state. It can only reduce its oxidation state. If it undergo reduction, it's a strong oxidizing agent. Is that clear, Mahavir? Copper plus HCl, Naren. See, Naren, it is from electrochemistry, beta. You can see if you do the reaction, copper is undergoing reduction and H plus is undergoing copper is undergoing oxidation, H plus is undergoing reduction. But you know reduction potential of copper is 0.34. Reduction potential of hydrogen is 0. So whose tendency to show reduction is more, copper or hydrogen? Copper. So how can copper undergo oxidation with hydrogen? So hydrogen cannot undergo reduction in presence of copper because reduction potential or tendency to do reduction for copper is more than hydrogen. So it is copper who will undergo the reduction, not hydrogen. Why? Because reduction potential of copper is more than hydrogen. Reduction potential is what? Tendency to do reduction. So if tendency to do reduction for copper is more than hydrogen, then who will do reduction? Copper. But in this reaction, who is doing reduction? Hydrogen. So therefore, this reaction is not possible. Is that clear now, Naren and Athar? Is that clear now, Naren and Athar? Yes. So let's move ahead then. Right. So now you observe there are two graphs you can see here. As you see, the graph from titanium increases till chromium. There is a sharp dip in manganese. Then it again increases till copper. Then there is a sharp dip in zinc. Correct? So it usually increases. Reduction potential become more positive as you go ahead. Right? If you follow the observed value. Calculated value graph, there are two more exceptions, that is cobalt and nickel. They are having low values. Correct? So two things we need to answer. First, why reduction potential is increasing from titanium to zinc? Correct? That's pretty obvious. Observed values and calculated values means observed means it is an experimental value, right? Calculated, which you have done through calculation, right? Now I'll come to that only. I'll come and explain this graph in detail. First, let me tell you your reduction potential value depends upon three energies. What are those? Enthalpy of atomization, ionization enthalpy, and hydration enthalpy. So it depends upon enthalpy of atomization, ionization enthalpy, and hydration enthalpy. So I can say these two energies are positive, whereas hydration energy is negative. So these two energy if increased increases the potential. If hydration energy is increased, since it is in negative, it will decrease the potential. So you can write here, it decreases reduction potential and these two increases reduction potential. Correct? Now we can come and explain our graph. So let me explain it here. So first thing is, I will explain the following things. Let me explain you the whole graph. So first thing is, why it increases from titanium to zinc. Why there is an increase first of all? Why the reduction potential increases? Because from titanium to zinc, enthalpy of atomization and ionization enthalpy, both of them increases. Correct? So let us write here, E reduction potential increases from titanium to zinc. This is due to increase in ionization energy and enthalpy of atomization. Generally, this is your first point. Now, what is our next agenda? Our next agenda is to counter these exceptions. So now, can you tell me why manganese has very low tendency to do reduction? We are plotting, remember we are plotting which potential? We are plotting E of M2 plus ion to M. So this is very obvious. Why manganese has very less tendency to convert from M2 plus to M? Low reduction potential means it will not get, yes Pritesh, very good. Very good. So if you take M, manganese 2 plus is half filled. Manganese 2 plus is half filled. So if it is half filled, it is stable. And if it is stable, will your Mn2 plus get converted into Mn? Will your Mn2 plus get converted into Mn? No. Why no? Because Mn2 plus is more stable. Why it is stable? Because it has half-filled stable configuration. So therefore, there will be a cross here. So this reaction will not take place, or tendency of Mn2 plus to get converted into Mn is very low. Therefore, Mn2 plus to Mn, there is a sharp decrease here. Is that clear, everyone? Now, why zinc? Why zinc has low value? Same reason. Zinc 2 plus is full-filled configuration. Zinc 2 plus is full-filled configuration. So tendency of zinc 2 plus to zinc is very low. Why? Because zinc is stable due to full-filled electronic configuration. Is that clear, everyone? So zinc and manganese is sorted, right? Zinc and manganese is simplified, correct? There is no problem with zinc and manganese. So they are our brothers now. We are happy with them, correct? Now what else we need to explain? We need to explain two more things. What are those? Let us go and explain two more things. What are those? Our cobalt and nickel. So if you talk about cobalt and nickel, right? If you talk about cobalt and nickel, so cobalt and nickel, you can see the values here. You can see the values here. Till iron, the value enthalpy of hydration. This is enthalpy of hydration. First ionization energy, second ionization energy, enthalpy of atomization. All three energies are given here. Okay? See, till here there is no, it has not touched 2000. But you check the enthalpy of hydration for nickel and cobalt. Nickel has the highest enthalpy of hydration, that is -121. So I would say cobalt and nickel have low reduction potential than expected because of high hydration energy. Because of high hydration energy. You can see here, I had told you hydration energy is a negative term. So it will decrease the reduction potential. Right? It will decrease the reduction potential. Correct? Now, copper 2 plus and nickel almost have similar hydration energy. Then you should say, sir, if nickel is small, then copper should also be less. If nickel reduction potential is less because you are saying hydration energy is more, then copper also has same hydration energy. It should also be low. Then what would you say? Why it is high? Why reduction potential of copper is high? Why reduction potential of copper is high? Because copper is having high ionization energies. Check the ionization energy: 1752, 1958, 736. First ionization energy is same. But what about second ionization energy? Very much difference. Right? In fact, copper has the highest second ionization energy. Second ionization energy is highest for copper. And as ionization energy increases, since it's a positive value, reduction potential will increase. So it has potential due to high ionization energy 2. High ionization energy 2. Is that clear, everyone? Yes? So before the exam, just go through the graph. In your notebooks, notes also, draw the graph, circle the exceptions and write the reason for the exceptions. That's the best way of practicing it. You can't remember the values. Here you have the values in front of you. But for notes, draw the graph, circle the exceptions the way I have done and write the reason why this is low, why this is high. Is that clear, everyone? Yes. Is that clear, everyone? अरे भाई clear है? Is that clear or not? Very good. So we can go ahead then if it is clear. Yeah. So here you can see, obviously, same grounds pe you can answer. Scandium plus 2 is highly unstable. So it will easily get converted into scandium plus 3. Right? So now here, similarly, Mn plus 2 is highly stable. Its tendency to get converted into Mn plus 3 will be very low. Fe plus 2 can get converted to Fe plus 3. Zinc plus 2 is highly stable. So its tendency to get converted into Zn2 plus is very low. It decreases. Correct? Is this clear? So this arrow represents the tendency or reduction potential for this process. Zinc 2 plus is stable, so zinc plus 3 will not be formed, so tendency is low. Then Fe2 plus to Fe3 plus. Fe3 plus is half filled, so it is more stable, so tendency is high. Mn2 plus is stable, so tendency is low. Scandium is less stable to scandium 3 plus, so tendency is high. Right? That is how you can explain this. Right? So just you have to see the stable electronic configuration. That's all. All right. So let's answer this then. This is the only question you will be able to get it on this. So yeah, this is what you see here. The correct order of reduction potential value with the sign, consider the sign also for 4 successive transition elements: chromium, manganese, iron, cobalt. Chromium, manganese, iron, cobalt. What will be the reduction potential values? Order of reduction potential value. Mark it carefully. With negative sign is an important topic here. It's an important topic here. Sorry, just a minute. Yes. Now you can check it. Now you can check it. Oh, it got locked. Guys, answer it carefully. I can only say you that. I'm giving you enough time for this. Do not fumble it up. Yes, so let's end this and discuss it then on account of 3, 2, 1, now. Yes, I'll show you the table. Right. So this is what the tricky part here, right? So you have to consider the negative sign means you have to check the values, right? So if you check the values, what are the values for different elements? See here, manganese is coming out to be between 1 point, how much? This is 1.4, let's say. Whereas chromium is 1. So what would we get after this? So chromium is 1, and then our next element is iron. Iron is 0.5, and this will be approximately 0.6. Correct? 0.6. Now, what does it mean in general? In general, it means maximum difference is for manganese, then comes your chromium, then comes your iron. Just a minute. Iron, and what is asked? Cobalt. Cobalt is here. Right? So the potential is maximum you can observe here is for manganese. This is how much? 1.4. This is for sure. Maximum is for manganese. Then chromium is 1. With negative sign, I'll tell you what is the meaning of it. Then this is a confusion actually. So we can say this is 0.5, this is 0.6. So cobalt should be before iron actually. Okay? So your answer with that comes out to be B. So actually it should be cobalt then iron, but I think they are close values. So you consider manganese first. Okay? Now, yeah, you can take the screenshot for the values. It is given the observed values. Let us check the observed values. Manganese में it is maximum. Then chromium में 0.9, iron में 0.4, cobalt में 0.28. So cobalt is minimum. You can check the overall observed values. So maximum is manganese. Then is your chromium. Then 0.44 is your iron, then this is your cobalt. So cobalt is minimum, correct? So I think based on these values, you can answer this question easily. But even if you don't know the values, you can answer it from the graph, right? It is correct option only, sir. Yes, it is a correct option. I was matching from the graph. That's why I was getting cobalt less than this. So maybe if they have given the values, then it's pretty simple, right? Even from the graph, you can answer this, right? On what basis we have to take? We have to take observed values, final values. Observed values graph only. But graph can be asked, any graph can be asked, observed or calculated. Any of those two graphs can be asked in exam, right? So yeah, that's all. I hope you have understood this. Let's move to our next concept. This is very important concept. All of you, please pay attention. Manganese shows +7 oxidation state with fluorides in this compound MnO3F. Right? Now observe this table carefully. What is this table trying to tell you? This table is trying to tell you that you observe these higher oxidation state with fluorides. Correct? Fluorides means you are getting the higher oxidation state. So lower oxidation states are possible with other halogens also, but higher oxidation state is possible only with fluorides. So let me write here, higher oxidation state halides are formed by fluorine. Why? Now the question is why? Why only fluorine can form higher oxidation state compounds? There are two reasons to that. What would be your first reason? The first reason is, do you remember electrochemical series? We had said something there. Which is the strongest reducing agent according to electrochemical series? We have discussed it there. Yes. Very good, Pratish. So which is the strongest reducing agent according to electrochemical series? Lithium is the strongest reducing agent. It lies at the bottom. Which was the strongest oxidizing agent? According to that series? Which lies at the top of the electrochemical series? Very good, Athar. It is fluorine. Not potassium vidya. It is fluorine. You can check the potential values after going home. It is fluorine. Fluorine is strongest oxidizing agent. So fluorine is strong oxidizing agent. Therefore, it can oxidize element to their higher oxidation state. Second reason is metal fluorine bonds are strong. So these two reasons are the reasons why fluorine forms, why most of the higher oxidation states are possible with fluorines. This is the first thing you should observe here. Now you should see here, if you go individual group, titanium can form TiX4, TiX3, TiX2. Now what is X here? X can be fluorine to iodine. That means titanium can form TiF4 to TiI4. All of them, all these halides are stable. Whereas it can form TiCl3, TiF3, etc. X triple dash. So what is your X triple dash? It can be chlorine or iodine. That means titanium fluoride is not stable. That means dihalide of titanium is possible only with fluorine to iodine. This is the information from the textbook. But there is no reasoning given there. Correct? Now, one more striking fact you should observe here. See here. +1 oxidation state is not given by any of them. None of them form halides in +1 oxidation state except copper. And copper also forms with which halogen? Fluorine to iodine. That means copper can form monohalide or halide in +1 oxidation state with fluorine to iodine. That means Cu, Cl exist, but CuF do not exist. What can be a reason? We have already given the reason. What can be our reason? We have already given our reason. We have said fluorine is strong oxidizing agent. Fluorine is strong oxidizing agent. If fluorine is strong oxidizing agent, will it oxidize if you react copper with fluorine? So fluorine will oxidize copper to copper plus 1 or copper plus 2. It will oxidize copper to copper plus 2, not copper plus 1. So therefore CuF is not stable. Similarly, if you react titanium with fluorine, it will oxidize titanium to titanium plus 3 and titanium plus 4. Whatever titanium plus 2 is formed, it will get oxidized to titanium plus 3 and titanium plus 4. Right? Similarly, I can ask, my question would be that only. Why TiCl2 exists, but TiF2 does not exist? Why CuCl exists, CuF does not exist? Right? Similarly, I can ask numerous questions on this table. This table is actually given in textbook also, but reasoning is not given. So I hope it is clear. Two questions from here. Fluorine acts as strong oxidizing agent. Therefore, fluorides are stable only in higher oxidation state. In lower oxidation state, fluorides are not stable. Fluorides are not stable. Is that clear, everyone? Yes, is that clear, everyone? Pritish, is that clear now? Yes. So let's move to our next thing. It's the same thing here. The same thing which I have explained you. Lower oxidation state is not possible except copper. Copper also forms from copper chloride to copper iodide. This is what I have already explained you. Lower oxidation state does not form fluoride. Why? Because fluorine is strong oxidizing agent. Or you can write a question, why CuCl exists but CuF does not exist. This is the question which can be asked. In the third column, just a minute, Adesh. In the third column, it is, in the fourth column, it is it MnX3 or FeX3? 1, 2, 3, 4. It will be Mn, Adesh. It will be Mn. Right? It will be Mn. Now, you can see the same reasons here. I have already given you the explanation for this. Right? So, now the question can be, see carefully, all of you, please see carefully. Copper plus fluorine gives you copper fluoride plus 2. Plus 2. Plus 2. But with iodine, no reaction. Can you tell me why? Why with iodine, no reaction? Why with iodine, no reaction? In fact, copper plus iodine will give you CuI, not CuI2. Why? Why? Why copper plus iodine will give you CuI, not CuI2? Can anybody explain this? Obviously, steric hindrance. More than that, we have already seen the reason. Fluorine is strong oxidizing agent. It can oxidize copper to copper plus 2. Chlorine can also, bromine can also. But iodine is a very weak oxidizing agent. Weak oxidizing agent. Since it is a weak oxidizing agent, it can oxidize copper to copper plus 1 only, not copper plus 2. Therefore, CuI2 does not exist. Very good, Abhishek. H. Great that. You got it. Let's do a question on this. Yeah, same thing with oxides also. Higher oxidation state are possible with oxides. Same thing, whatever you have studied for fluorides. So higher oxidation state is possible for oxides also in the same way as we have done for fluorides. Right? So the question comes, most of the higher oxidation state are either present as oxides or fluorides. But oxides are more stable than fluorides. Why? Because oxygen can form multiple bonds. So देखो, I had told you why fluorine gives that, because we have said metal fluoride bonds are strong. Similarly, metal oxygen bonds are also strong. Then why oxides are further more stable? Because oxides have tendency to form multiple bonds. More is the number of bonds, more is the stability. Right? Yes, Naren, it decreases. Reduction potential values, Naren, you can check. Right? So let's try to answer this question and end it up. Consider the following transformations. Then if CuX2 gets converted into CuX, what can be your X easily? At room temperature, CuX2 gets converted into CuX. What can be your X? What can be your X? Let me give you options. What can be your X? So it's a critical one. Chalo, let's discuss this. We'll end it on a count of 3, 2, 1 now. So let's try to end it up. Yeah. So you can see this. I have already told you CuI2 is not stable. CuI is stable, right? So you can see here, if it was CuI2, it will easily convert into CuI. Only one option includes I, that is C. So your answer has to be C. Okay? Your answer has to be C. CuCl2 and CuBr2 are stable. So therefore, you cannot answer B. Right? That's all for today. Let's finish our quiz also in 1 minute. It's an interesting one. I don't know whether you'll be able to understand it or not, but it's a good one. Yeah. So this is what you have. Vishal, it was C beta, not B. Saint Mary Magdalene Church is located in Trivandrum. It's a magnetic equator, right? All of you know what is magnetic equator. It caught attention of X and thus went out to become the first site for something. Tell me what is that something? Identify the X. Recently on August 12, Google launched a following doodle as a tribute for 100th birthday anniversary of X. I'll show you the doodle. This was the Google doodle which was launched. This was the Google doodle which was launched. I can show you the question here now. Yeah, otherwise got it wrong. Otherwise got it, I guess. Not that Ashutosh, not Naren, not that. So it was basically Vikram Sarabhai. The first rocket was launched from that location, magnetic equator. The first rocket was launched from that location, that is magnetic equator, right? All right. Yes, Visma, you are right. Chalo, that's all. Take care, all of you. Yes, father of ISRO. Thank you, Pavitra. YC is correct answer. Yes, for sure. I have already explained it before only. Sakshi, just a minute. Yeah. Sakshi, if you see this, here I have explained that copper on combination with iodine forms CuI +1, not +2. Why? Because +2 is not stable. Or you can say I2 is a weak oxidizing agent. It will oxidize copper only to +1, not to +2. Okay? So CuI2, if it is present, it will easily get converted into CuI because copper 2 is not stable. Copper +1 is stable with iodine. Okay? Therefore, in this question, CuX2 is getting converted into CuX. That means +2 is getting converted to +1. Which halogen? Iodine. CuI2 will easily get converted into CuI because CuI is more stable, right? Whereas CuCl2 and CuF2 are formed, but CuI2 is not formed because it is not stable. So it will easily get converted into. Why do you want that, Adesh? Right? I did not understand your point. Thank you, Chetna. Thank you, Sakshi. It's okay, Ray. I'll send you a link, Adesh. You can play that yourself. Thank you, Manisha. I did not get your question, Kishore. You can message me on WhatsApp, beta. Right? So we got another class lined up. Siddharth, remind me in the beginning of the class tomorrow. I will discuss it. Everybody is gone now. Siddharth, thank you, Adesh. Siddharth, remind me in the beginning of the class tomorrow. I'll share it on the slide only. Okay? Oh, take care, beta.